K-means clustering is a versatile algorithm that can be used for any type of grouping. Let's look at a few examples of use cases. In behavioral segmentation, there are segment by purchase history, segment by activities on application, website, platform, define personas based on interest, and create profiles based on activity monitoring. When we talk about inventory categorization, we have group inventory by sales activity and group inventory by manufacturing metrics. When we talk about sensor measurements, the different activities are detect activity types in motion sensors, group images, separate audio, and identifying groups in health monitoring. When we talk about detecting bots or anomalies, there are separation of valid activity groupings from bots and group valid activity to clean up outlier detection. In addition, monitoring whether attract data point switches between groups over time can be used to detect meaningful changes in the data. To run a K-means algorithm, randomly initialize 3 points called the cluster centroids. There are 3 cluster centroids in the image shown here as data is grouped into 3 clusters. K-means is an iterative algorithm and it involves 2 steps: cluster assignment and move centroid step. In cluster assignment, algorithm travels through data points, depending on which cluster is closer. It assigns it to the red, blue, or green cluster. In the next step, we move centroid. The algorithm calculates the average of all the points in the cluster and moves centroid to the average location. These 2 steps are repeated until there are no changes in clusters or when the specified condition is met. K